Hello Year 7s and welcome to Physics Corner with Miss Ellery. Hang on, that didn't work. Let me get my physics hat. Let's try that again. And welcome to Physics Corner with Miss Ellery. Today we're going to be learning about the difference between mass and weight. In everyday life we generally conflate the two, which means that we use them interchangeably, or we use them basically to mean the same thing, but they're actually very different. So, hang on, just let me take this off. Here we have a 2.5 kilogram dumbbell, or as we also call them, a 2.5 kilogram weight. But does the 2.5 kilograms refer to its mass or its weight? Well, let's get some definitions out of the way first, shall we? Let's start with mass. Mass refers to how much matter something is made up of. You might remember that we talked about matter last term during chemistry. All physical things are made of matter, and all matter is made of these tiny little particles called atoms. So when we're talking about mass, we're really talking about how many atoms something is made up of. And we measure mass in milligrams, grams, and kilograms. Hi, mass. Weight, on the other hand, is actually a force. I know, right? Wait, that can't be right. No, it says right here that yes, weight is a force. Weight is actually the measure of gravity's pull on a certain object. And we get the value by multiplying the mass of something, in kilograms for example, by that particular planet's gravitational pull. So for us, it would be Jupiter. I mean Earth. I always get those two confused. Now, because we know now that weight is a force, that means that we must know that it's measured in... What was that, class? That's right! Weight is measured in newtons. So you may have realized by now that when you're looking at something measured in kilograms, that's talking about the mass of that object. So anything that you read on a scale, or, you guessed it, this dumbbell is referring to the mass of the object. In other words, how much matter it's made up of, or how many particles are in it. So if we put something on a scale to figure out its mass, then how do we figure out something's weight? Well, here is where the beauty of maths comes in. We find something's weight by this equation. F equals m times a. Let's break that down. F stands for force, and the force we're looking at right now is... Good job, class, you are so good. Weight. So F in this scenario stands for weight. M stands for mass. So let's use my mass for an example, which is 60 kilograms. A stands for acceleration due to gravity, but for our purposes, we'll just say gravity. The Earth's gravity is 9.8 meters per second squared. So now that we've put everything into the equation, we can find out what my weight is on Earth, which, as it turns out, is 588 newtons. Now, let's get something straight. My mass will always be the same. I'll always have the same amount of particles in me. Unless, my arm gets chopped off. But assuming that my arm won't get chopped off, my mass is the same no matter where I am in the universe. I have 60 kilograms on Earth, on Mars, or even floating around in space. So my mass is always the same, but my weight will be different. You know how people say that in space you're weightless? Well, that's actually true, because there's no gravity in space. And since there's no gravity in space, this means that there's no weight force acting on you. Your weight on other planets, on the other hand, depends on the gravity of that planet. Coming back to our equation from before, if we input Jupiter's gravity, we can find out that my weight on Jupiter would be 1,470 newtons. On Mars, 220 newtons. So you can see I weigh a different amount on each planet because the gravity on each planet is different. Bigger planets have more gravity and smaller planets have less. But my mass is always the same. The amount of me does not change. So that's it. That's the difference between mass and weight. And now you get to be that annoying person that tells someone, oh no, you don't weigh this amount, that's your mass, silly. I hope that you have enjoyed this video. As always, if you have any questions, please direct them to myself, Mr. Shield, or Mr. James. And otherwise, I hope you all have a wonderful day. Bye! Let's do some definition. We use them...